India's space journey has steadily evolved from satellite launches to deep space exploration missions such as Chandrayaan and Gaganyaan under the leadership of the Indian Space Research Organization. These programs laid the technological and human capability foundation for long-duration mission in low Earth orbit. India is now moving towards establishing its own indigenous space station named the Bharatiya Antariksha Station (BAS). This station represents the next logical step in India's human spaceflight roadmap, enabling sustained astronaut presence, advanced microgravity research, and preparation for future missions to the moon and beyond. Bharatiya Antariksha Station. The Bharatiya Antariksha Station (BAS) is India's planned modular space station designed for long-term scientific research in low Earth orbit at an altitude of 400 to 450 kilometers. It will allow Indian astronauts to stay in space for extended duration of 3 to 6 months. It is planned online similar to the International Space Station. BAS will consist of 5 modules launched in phases. The first module BAS-01 is targeted for launch in 2028 with the complete station expected to become fully operational by 2035 under ISRO's long-term space vision. Bharatiya Antariksha Station background. Idea of Bharatiya Antariksha Station emerged as a natural extension of India's human spaceflight ambitions under Gaganyaan and long-term space exploration goals. Gaganyaan, approved in December 2018, aimed to develop technology for safe human spaceflight to low Earth orbit, forming the technological base required for a future space station. Short-term orbital missions were insufficient to study long-term effects of microgravity on humans, creating the need for a permanent orbital laboratory. India's space roadmap envisions an operational space station by 2035 and a crewed lunar mission by 2040, positioning BAS as a critical intermediate milestone under Amrit Kal Vision 2047. On 18 September 2024, the Union Cabinet approved expansion of Gaganyaan to include development of BAS-01 and precursor missions. Establishing BAS enhances India's autonomy in human spaceflight, scientific research, and strategic space capabilities and growing global space competition. Bharatiya Antariksha Station features. The Bharatiya Antariksha Station is designed as a technologically advanced, modular, and internationally compatible orbital research facility. Modular configuration. BAS will consist of 5 interconnected modules allowing phased construction, easier upgrades, and operational flexibility over its planned lifespan. Orbital characteristics. The station will orbit Earth at approximately 400 to 450 km, ensuring stable microgravity conditions suitable for scientific experiments. Funding. Revised Gaganyaan funding stands at ₹20,193 crore, including an additional ₹11,170 crore approved specifically for BAS development and missions. Mission planning. 8 human spaceflight related missions are planned under the revised program, concluding with BAS-01 launched by December 2028. Interoperability standards. BAS-01 subsystems are being designed following international standards to enable docking and collaboration with global space agencies. Bharatiya Antariksha Station modules. The Bharatiya Antariksha Station will be constructed using 5 spaceflight modules launched using India's heavy lift launch vehicle. BAS-01 base module target to be launched in 2028, measuring 3.8 meter in diameter and 8 meter in length, weighing around 9 to 10 tons. It houses crew quarters, life support, docking, and berthing systems. BAS-02 core module. Designed for docking and station control, this module will support structural stability and internal system integration. BAS-03 Science Research Module dedicated to microgravity experiment in biotechnology, material science, and human physiology. BAS-04 Laboratory Module enables extended experimental setups, long-term observation, and technology demonstration in space conditions. BAS-05 Common Berthing Module facilitates cargo docking, crew transfers, and expansion capabilities, supporting station logistics and maintenance. Bharatiya Antariksha Station development. The development of Bharatiya Antariksha Station follows a phased technology-driven roadmap integrated with Gaganyaan mission and indigenous system development. Timeline progression. First module launch is targeted for 2028, while complete 5-module operational capability is planned by 2035. Technology demonstration missions. 4 dedicated missions between 2026 and 2028 will validate life support, docking, robotics, and long-duration habitation technologies. Launch vehicle BAS module will be launched using LVM-3, LVM-3SC, and future next-generation launch vehicle to handle heavy payloads. Robotic systems. A robotic arm tested on POEM-4 in January 2025 will assist in module assembly, maintenance, and external operations. Industry participation. ISRO has invited commercial players since January 2026 for module construction, increasing private sector involvement. Bharati Antariksha Station significance. The Bharati Antariksha Station holds transformative significance for India's scientific, technological, economic, and strategic ambitions. Microgravity Research Hub. BAS will enable advanced research on muscle atrophy, bone density loss, fluid behavior, and material processing in microgravity. Human spaceflight capability. Long duration missions will help develop medical, psychological, and life support solutions essential for future lunar and deep space missions. Economic growth. India aims to raise its global space economy share from 2% to 10% with BAS driving high-tech manufacturing and innovation. Technological spin-offs. Space-developed technologies will benefit sectors like healthcare, environmental monitoring, construction, and advanced materials. STEM inspiration. BAS offers career opportunities for youth in space science, engineering, and research, strengthening India's knowledge economy. Bharati Antariksha Station challenges. Despite its promise, the Bharati Antariksha Station faces several technical, financial, and strategic challenges. Complex life support systems. Developing reliable systems for oxygen, waste recycling, radiation shielding, and thermal control is technologically demanding. Astronaut health risk. Microgravity, radiation exposure, psychological isolation, and altered brain fluid dynamics pose serious health challenges. Limited funding. India's research and development budget stands at around 0.7% of GDP, which may constrain advanced technology development pace. Space debris threat. Increasing orbital debris heightens collision risk requiring advanced tracking and avoidance systems. Geopolitical sensitivities. Balancing strategic autonomy with international collaboration remains complex in a competitive global space environment. Way forward. International collaboration. Cooperation with experienced agencies like ESC, NASA, and Roscosmos can reduce cost and technological risk. Enhance funding models. Greater public-private partnership and international collaboration can supplement national funding constraint. Capacity building. ISRO must upgrade infrastructure for life support, radiation protection, and orbital maintenance technologies. Sustainability planning. Regular resupply missions, modular upgrades, and maintenance strategies are essential for station longevity. Regulatory compliance. Adherence to international space law and sustainable space governance norms is critical for long-term operations. International Space Station. The International Space Station is the world's largest operational space laboratory and serves as a benchmark for global cooperation in space. ISS is jointly operated by NASA, Roscosmos, ESA, JAXA, and the Canadian Space Agency, involving 15 countries. Assembled in 1998 and operational since 2008, has hosted continuous human presence for over 2 decades. More than 3,000 experiments from over 108 countries have been conducted aboard the ISS. Orbits Earth at around 400 km, similar to the planned orbit of BAS, enabling comparable research conditions. ISS experience provides valuable lessons in long-duration missions, international coordination, and station sustainability. Space stations. A space station is a habitable artificial satellite designed for long-duration human stay, research, and experiment in Earth orbit. The list of other space stations that have been managed by the countries across the world is given below. Salyut 1. Soviet Union inoperative. Launched in April 1971, it was the world's first space station and marked the beginning of long-duration human space habitation experiments. Skylab United States inoperative. Launched by NASA in 1973, it was America's first space station and conducted extensive solar and biomedical research before deorbiting in 1979. Salyut series USSR inoperative. Between 1971 and 1986, several Salyut stations were launched to test military and civilian space station technologies. Mir Space Station, Russia inoperative. Operational from 1986 to 2001, Mir was the first modular space station and supported long-duration missions exceeding 1 year. International Space Station operational. Operational since 2000, jointly run by NASA, Roscosmos, ESA, JAXA, and CSA, and the largest habitable structure in low Earth orbit. Tiangong Space Station, China operational. Fully operational since late 2022, China's modular space station supports the three-member cruise and advanced microgravity research. Bharatiya Antariksha Station, India's planned modular space station with 5 modules. First module launch are targeted for 2028 and full operation by 2035. Gateway Space Station upcoming. A NASA-led international project under the Artemis program planned to orbit the moon and support deep space and lunar missions. Axiom Space Station upcoming. The world's first planned commercial space station to be built in low Earth orbit and eventually replace ISS modules. Russian Orbital Service Station ROS upcoming. Russia's proposed next generation space station intended to replace its role in the ISS after retirement.